guys, it's Ashraf from WiZ.edu, and today we're going to be going through type 2 trigonometry questions, which are equations with restrictions. So what exactly are type 2 trig questions? Well, basically, you will be given a trigonometric equation and you'll be given a restriction. And using these, you'll be required to find the value of other trigonometric expressions. So what exactly would a type 2 question look like? Well, here's an example. We're given 5 cos theta equals 3, which is our trig equation, and we are given a restriction. We are told that theta is between 90 degrees and 180 degrees. So we are given a trig equation and a restriction, and here we are asked to find the value of another trig expression. So this is the type of question you'd get in an exam. So just a word about restrictions. We basically have 3 main ways in which we can represent a restriction. We have case 1, case 2, and case 3. So the first one is the one I've already shown you, which is called inequality notation. So this is called inequality notation because you can see we have inequalities here. And this restriction is basically telling us that the angle theta lies between 90 degrees and 180 degrees. So it's basically telling us that the angle theta lies in the second quadrant. And a little bit later, we'll go into detail about why this is important. The second way in which you can represent a restriction is something that's called interval notation. And it's something we would have done in algebra, and it's something that you are expected to know, especially for question 1 of maths paper 1. So this restriction is exactly the same as the restriction in case 1. Whilst it may look different, it's telling us exactly the same thing. Case 2, over here, it's telling us that theta is an element of 90 degrees to 180 degrees. So it's basically telling us that theta lies between 90 and 180. And because these are square brackets over here, it means that it could be also equal to these. So it basically means this here, that theta is less than or equal to 180 and greater than or equal to 90 degrees. So it's also an indication that theta lies in the second quadrant because it's telling us it's between 90 and 180 and could also include 90 and 180. And the third case, which is probably the easiest case of representing a restriction, is to just tell you that theta lies in the second quadrant. So you are told that theta is in the second quadrant, and from that you can then infer that theta is between 90 and 180. So these are 3 ways you could be shown a restriction in an exam question. So now what's the method that we would use to solve a type 2 question in which we are given a trig equation and a restriction, and we are required to find the value of other trig expressions? Well, let's go through the method. The first step you would use to answer these questions is to make sure that the trig equation you are given is in the form of trig function equals number. And we'll go through in the example we're about to do quickly what that exactly means. The second step is to find the appropriate quadrant by looking at the restriction and the sign on the right-hand side. So we've already done a little bit about restrictions, and we showed how if something is between 90 and 180, it lies in the second quadrant. So you're going to use the restriction to find the quadrant you're working in. The third step would be to put the definition of the trig function of the right-hand side and use that to extract variables and find the missing variable using Pythagoras. So for example, if you had sine theta equals 3 over 5, you'd put in your definition on the right-hand side, which is y over r. And from there, you could infer that y is 3 and r is 5. And then you could use Pythagoras to calculate x, because we know that x squared plus y squared equals r squared. And then your fourth step is going to be to immediately assign the correct sign to each variable. This means that using your restriction and the quadrant you're working in, you'd have to find the correct sign for each variable. So for example, if you are looking at quadrant 2, we know that in quadrant 2, x is negative and y is positive. So when you got your variables from the question, you'd have to assign a positive value to y and a negative to x because you would be working in the second quadrant. And for your fourth step, you'd complete the question by using the three variables and inputting them in to the value of the trig expression you're trying to find. So let's go ahead and try an example. So we'll keep our method here on the left just so we can go through it. And we'll try this example here, where we are told that if 5 sine theta equals 3 and theta is between 90 degrees and 180 degrees, what would the value of cos theta be? So step 1 is to get the trig function equal to a number. So you can see that the trig function 5 sine theta equals 3 is not in the form of trig function equals number. Because when you're trying to get it into the form trig function equals number, there has to be just a trig function on the left-hand side and everything else has to be on the right-hand side. So how we do that is we divide the entire equation by 5 to get rid of the 5 on the left. So that would then become sine theta equals 3 over 5. And we are now in the form trig function equals number. So step 1 is complete and we can go on to step 2, which is to find the appropriate quadrant by looking at the restriction and the sign on the right-hand side. So we are told that theta is between 90 degrees and 180 degrees. And this basically tells us that because 90 is there and 180 is there, this is our first quadrant, this is our second quadrant. We are basically told that theta lies within the second quadrant. So we know that in the second quadrant, x is negative and y is positive, and r is always positive because it refers to the radius, which is a length, and length is always positive because it's a scalar quantity that you should know from physics. So now we've completed step 2 because we know which quadrant we are working in. And now we go on to step 3, which is to put the definition on the right-hand side and find the missing variable using Pythagoras. So the definition of sine, we know, is y over r. So from this, we can extract y to be 3 and r to be 5. And now we can use Pythagoras to find x because we know that x squared plus y squared equals r squared. Reason is Pythagoras. So we can substitute y and r in, and that gives us x squared equals r squared is 5 squared minus y squared, which in this case is 3 squared. So we have x squared equals 25 minus 9. So x squared equals 16. And to get rid of the exponent, we can square root both sides. So root 16 is 4. But now, remember that step 4 is to immediately assign the correct sign to each variable. Now, whenever you square root something, there could always be a plus or a minus, because we know that minus 4 squared equals 16, and 4 squared gives us 16. So final answer could be plus or minus 4. And now we have to choose, are we taking plus 4 or minus 4? And in this case, we are going to take minus 4 because we are working with the second quadrant, right? And we've identified that in the second quadrant, x is negative and y is positive. So our y will remain positive 3 and our x will be negative 4. So from this, we can go on to solve the rest of the question because we've done step 4 and now we can just go on to step 5. So I'm just going to erase all this here. And we can say for theta, our x, y, and r are the following. We've calculated x to be negative 4. Our y is positive 3, and our r is positive 5. So now we can use this to solve for cos theta because we know that the definition of cos is x over r. So we come back here and see that x is minus 4, r is positive 5. We immediately substitute those in, right? And our final answer is negative 4 over 5. So if 5 sine theta equals 3, cos theta will equal negative 4 over 5. Thanks for watching, guys. Please try out some more questions on type 2. The link to a worksheet will be in the description below. And in the next video, we'll go through some more examples. Thanks for watching, guys.